This video is about an application of the common ion effect. It's about a very particular way to combine a common ion to get a result that we want. A buffer, I'm sure you will remember from biology, is a solution that resists changes in pH. You can add a little bit of acid, you can add a little bit of base. pH doesn't change all that much. I'm sure you can imagine how important that would be for a biological system. So it's something that comes up in biology over and over and over again. Now, in order to make a buffer, you mix together an acid and the salt of that acid, just like this problem we did in the last video. You could actually do a base and the salt of the base too. That's true. And usually the amounts are pretty similar. The best buffers have the same concentration of the acid and the salt of that acid. Let's think about why this kind of a solution resists changes in pH. I'm just going to isolate out the ice box and the K equation. Let's say I added in a little bit of HCl. Now, mind you, I can't add too much acid, too much base. You can overwhelm the buffer. So what we're talking about is little bits. But let's say I add some HCl. What will happen? Well, HCl is a strong acid, so it's going to break up into H plus Cl minus, right? No more HCl in the beaker, only H pluses, Cl minuses. Cl minus, again, just like the Na plus, weak. Weak, weak, weak. It's not going to do anything. It's just going to sit there. It's a spectator. We can pretty much ignore it. Still there, we're just ignoring it. What we do have to worry about is this H plus. In our beaker, we have a heck of a lot of HClO2. We have a smidge little bit of H plus, and we have quite a considerable amount of ClO2 minus. Of those three things, those three species, which would the H plus react with? Well, this is a plus, so it would react with the negative. All right? So if I have just a little bit of H plus here and a lot of ClO2 minus, what's going to happen is some of this ClO2 minus is going to neutralize that H plus and make some more of this. All right? That's exactly what's going to happen. H plus ClO2 minus makes HClO2, which changes this line. Let's say I added 0.02 moles of H plus. That would change this guy to 0.08 plus X, and this guy to 0.12 minus X. Okay? I used up 0.02 of that and added it in over there. Stoich, essentially. If you think about how this is going to change this equation, not really very much. 0.08 there, 0.12 there. You went through that whole thing and solved it. You'll find it doesn't come out to be very far different from the problem we solved in the previous video. Same thing would be true if I added a base. Think about adding NaOH. Now what would NaOH do? Again, it's strong. It would totally dissociate. No more of this left. It's totally dissociated. It's totally broken apart. Na plus, very weak. Doesn't see anything it wants to react with. It's just going to sit there and observe the goings-on. Spectator. But the OH minus, now that's going to react with something. Let's see. What should it react with? It's not really going to react with the H plus because I just don't have very much of it. It's going to actually react with my acid. So I'm going to have OH minus plus HClO2 making water plus ClO2 minus. So what's going to happen here is I'm going to have the exact opposite of what I had here in the black. I actually use up some of this and make some more of that. So maybe it's this time 0.08 minus X and 0.12 plus X. Okay, once again, small amounts. It's always small amounts, otherwise you're going to overwhelm the buffer. And once again, that's going to change this equation. But because you've got this basically same thing on the top and the bottom, the pH is not going to change that much. That's what a buffer is.